Moving on to another question from the year 2015 for what 4 marks. A refrigerator converts 100 grams of water at 20 degrees Celsius to ice at minus 10 degrees Celsius in 35 minutes. And we are asked to calculate the average rate of heat extraction in terms of watts. Remember, what does this unit of watts measure? It measures power, right? Electrical or thermal power, right? The average rate of heat extraction. Whenever you say rate of heat extraction, rate means upon T, right? So heat energy upon time T is nothing but power, the unit of which is watts. So we are clearly asked to calculate the power required. How will we calculate the power required? Remember, initially the water which is at 20 degrees Celsius will first cool down to water at 0 degrees Celsius. The amount of heat required would be mc into delta T over here, delta T being 20. And this water at 0 degrees Celsius will further convert to ice at 0 degrees Celsius. The amount of heat required over here, let us call it Q2. This will be M into L, L being the specific latent heat of fusion of ice, right? Finally, this ice at 0 degrees Celsius will convert to ice at minus 10 degrees Celsius, right? The amount of heat required here, Q3, would be M into C into delta T. Delta T would be 10 degrees Celsius over here, right? C is nothing but the specific heat capacity of ice. So the total heat required would be Q1 plus Q2 plus Q3. So let us club our given data. Mass of water is 0.1 kgs. Temperature of water is 20 degrees Celsius. Amount of heat extracted to convert water from 20 degrees Celsius to water to 0 degrees Celsius we have seen is mc into delta T, right? So Q1 is equal to mc delta T for water, which is nothing but 8400 joules. T being 20 degrees Celsius. Amount of heat extracted to convert water at 0 degrees Celsius to ice at 0 degrees Celsius. This process Q2 is equal to M into L, that means mass of ice times the specific latent heat of fusion of ice, right? So M into L is simply 33,600 joules. Finally, the amount of heat extracted to convert ice at 0 degrees Celsius to ice at minus 10 degrees Celsius. Notice delta T is 10. This again would be mc delta T. That is the third process over here, Q3, right? So Q3 turns out to be finally 2100 joules, wherein C ice is the specific heat capacity of ice, which is 2.1 joules per gram per degree Celsius. Finally, the total heat required is the sum of the three, that is Q1 plus Q2 plus Q3. Total heat required therefore is 44,100 joules. And we are asked to calculate the power. Power we know is the total heat upon total time required, right? Total time required is 35 minutes. Convert minutes to seconds. That is nothing but 35 times 60 seconds. Notice we are asked to calculate the power in watt, right? What exactly is 1 watt? It is nothing but joule per second. So if we have a total heat in joules, we need to convert the denominator to seconds. So the power required would be 44,100 joules upon 35 times 60 seconds, and thus we can say the total power required is 2.1 watt. That's gonna fetch you 4 marks straight away for one such question in the year 2015. A very important question indeed. Moving on, we have another question from the year 2016 for what 2 marks. We are asked to calculate the mass of ice required to lower the temperature of 300 grams of water at 40 degrees Celsius to water at 0 degrees Celsius. Now notice over here, the final temperature is 0 degrees Celsius. So the heat gained by the ice will be nothing but m into L. This ice which has just melted remains at 0 degrees Celsius, so we do not need an extra mc into delta T, right? We will not be requiring this. So the total heat gained by the cold body will remain as m into L, right? What is the heat lost by the hot body? The hot body being water. Heat lost by the hot body will be simply mc delta T, wherein delta T is 40 degrees Celsius. Remember, water is being cooled from 40 to 0 degrees Celsius. So m into L will be equal to mc into 40 degrees Celsius, right? So let us club our given data. So we can say heat extracted by ice at 0 degrees Celsius to simply melt is equal to heat given by the water to reach 0 degrees Celsius from 40 degrees Celsius, right? Applying this equation, m into L is equal to mc into delta T. Mass of hot water is given to be 300 grams, right? Multiplied by specific heat capacity of water is given to be 4.2 joules per gram per degree Celsius, right? Times 40 will be equal to mass of ice is to be calculated times L being the specific latent heat of fusion of ice, that is 336 joules per gram. So this is the equation that we get solving. The mass of ice is straight away 150 grams, and we can thus say that the ice required to lower the temperature of water is 150 grams. As easy as that. That's gonna fetch you 2 marks straight away for one such question in the year 2016. Very important indeed.